Part 1. Hey friends, want me to show you a magic? Come on then, observe me carefully. Watch me put these solutions one by one on this magical paper. Did you see how I got different colors every time I put these solutions on this paper? You must be surprised, aren't you? Are you sure this is a magic? Oh, come on. This is no magic. This is simply science. In fact, the liquids that I used are different, and this special paper strip is called a pH paper. Now you all must be eager to know what a pH paper is and how does it show different colors with different solutions. Let us discuss this in detail. We know that an acidic solution contains hydrogen ions, that is H+ ions, and a basic solution contains hydroxyl ions, that is OH- ions. Another important fact to remember is that a solution with more H+ ions is more acidic. That is, a strong acid. While the one with more OH- ions is more basic. That is, a strong base. To determine how strong a given acid or a base is, we make use of a universal indicator, which is a mixture of several indicators. This universal indicator gives different colors at different concentrations of hydrogen ions in a solution. Strength acid and base solution pH value, Part 2. We use a specific scale for measuring the hydrogen ion concentration known as the pH scale. The pH of a solution is a number which indicates the acidic or basic nature of a solution. It ranges from 0 to 14. The pH of a neutral solution is 7. Values less than 7 represent acidic solutions, while those greater than 7 represent the basic nature of solutions. If the acidic nature increases, that is, the hydrogen or hydronium ion concentration increases, the pH goes down. On the other hand, if the basic nature increases, the pH of the solution goes up. Generally, paper impregnated with the universal indicator is used for measuring pH. Such paper is known as the pH paper. Let's take different solutions and observe each on different strips of pH paper. Now observe the different colors that these solutions give with the pH paper on this table. Can you conclude something from this difference in color? Yes, we can identify whether the given solution is acidic or basic. pH value, Part 3. The strength of acids and bases depends on the number of H+ ions and OH- ions produced, respectively. Let us understand this with the help of an example. If we take hydrogen chloride and acetic acid of the same concentration, say 1 molar, then these produce different amounts of H plus ions. Acids that give rise to more H plus ions are said to be strong acids, while the ones that give less H plus ions are said to be weak acids. Similarly, if we take two bases of the same concentration, say 1 molar NaOH and 1 molar NH4OH, then the base that gives more OH minus ions is a strong base, and the one that produces less OH minus ions is considered a weak base. Now I'm sure you have identified the reason why the different solutions were giving different colors with the pH paper. It is because of the different strengths of the solutions that differentiates them into strong and weak acids and bases. pH is the measure of H plus ions present in a solution, indicating the acidic or basic strength of the solution. The pH of a neutral solution is 7. Values less than 7 on the pH scale represent an acidic solution. Whereas, with the increase in the values from 7 to 14 on the pH scale, the basic strength of the solution increases. Our body works within the pH range of 7 to 7.8. pH of acid rain is 5.6. When the water from the acid rain flows into rivers, it lowers the pH of the river water, which causes lots of damage to the aquatic life. Plants also require a specific pH range for healthy growth. You know that our stomach produces hydrochloric acid, which means its pH is less than 7. Excess production of acid by the stomach causes pain and irritation. We usually take antacids to get rid of this pain. For example, magnesium hydroxide, that is MgOH2, is an antacid which neutralizes the excess acid. Also, after eating, the bacteria present in the mouth starts producing acid due to the degradation of sugar and food particles left over in the mouth. This reduces the pH of the mouth below 5.5, and the tooth enamel, which is made up of calcium phosphate, that is Ca3PO4(2), which is the hardest substance in the body, starts decaying. Therefore, it is advised to clean the mouth after eating food using some toothpaste. These toothpastes are generally basic in nature. When a bee stings someone, it leaves some acid which results in pain and irritation. Using mild base like baking soda can give some relief when applied over the affected area. Similarly, nettle leaves produce stinging sensation when contacted because they inject formic acid, that is HCOOH, which results in burning pain. Rubbing some leaves of dock plant over the affected area provides relief to the irritation.